Projectile motion, right? Perfect. Note on the projectile motion. It's a very important. Now, so the velocity of projection and this, suppose that I'm throwing the ball or maybe some stone I'm taking that I'm projecting with some velocity called u, that is making an angle alpha. What about the horizontal component? Suppose I'm throwing with some velocity u. Yeah, I can explain you over here. Suppose I'm throwing the ball with some velocity u with an angle alpha, right? What about the horizontal component? You can able to resolve u into cos alpha. And what about the vertical component? U into sin alpha, right? Suppose that it is keep on falling on this projectile motion. It is keep on following. It is keep on falling. Now at the top of the particular projectile motion, what will be the velocity? At the top of the basically projectile path, what will be the velocity? Suppose height is what? Now it has traveled some height. That height we calling h. That height I'm calling what? H. Now that height will be called as what? Total projectile height of the particular particle. At this particular point, the velocity will be only horizontal component, right? There will not be any vertical component. Am I right? This Vy will be 0 or Uy will be 0. Only it will be having what? Ux component. This only component will be there. At any particular path, at any particular point of time, it is got two component like this. But at the top of the path, when it is reaching exactly at the top, it is going to have only one velocity, that is in the linear direction, right? Not in the vertical direction. Right? Now, it is under the gravity effect. Whatever the motion is happening under the gravity effect. Whenever the motions are happening under the gravity effect, what about the acceleration? Plus g or minus g? Plus g or minus g. Suppose I'm taking in the downward direction, that is plus g. Suppose if I'm taking in the upward direction, acceleration will be minus g. Yes or no, guys? Check it out. If any particle is traveling in the vertical direction, if it is moving towards the earth, that means gravitational affection is there, right? There will be one positive support that will be provided by the earth, that is plus g. When we are throwing the ball away from the ground, above the ground, or just we are throwing in the upper direction, vertical upper direction, then what we are doing? We are doing the work against the gravity, that means minus g. Whenever there is acceleration, my dear friend, what about the acceleration in the x direction? Whatever the acceleration I'm talking, that is I'm talking about ay. What about the acceleration in the x direction? Anybody know? It is under the gravity effect. Whenever it is under gravity effect, so acceleration in the x direction will always be 0. Yes or no, guys? Acceleration in the x direction will always be 0. Am I right? Please check it out. Perfect. Perfect. Now, the second thing will be important over here. When we apply the equation, Newton's equation, when we are going to apply the Newton's equation, so what we are going to write, my dear friend? What is the equation we are having? B is equal to u plus at. This equation I'm going to formulate in terms of what? In the vertical direction. I'm going to apply. In the vertical direction, what I'm going to apply? This particular equation of motion. For the vertical direction, in the vertical direction, what will happen? Vy will be equal to what? U naught y plus ag into or ay into t. Now, what is going to happen in the vertical direction? Initially, I'm throwing the ball in the upward direction. Then what about Vy? Vy will be u naught y will be what? What about u naught y? What is the initial velocity in the y direction? U into sin alpha, right? Minus g into t. Check it out whether this equation is clear or not. Initial velocity minus g into t, because we are throwing in the vertical direction, vertical upward direction. So acceleration will be what? Minus g. In the horizontal direction, try to apply the equation of motion. In horizontal direction, when you apply, Vx will be u naught x plus ax into t. This will be 0, my dear friend. So Vx will be what? Vx will be u into cos alpha always. Please note down, these are the very important. If somebody will ask you at any point of time, if somebody will ask you what is the velocity, what is the net velocity, then you will find the resultant of these two. Velocity at any point of time. Note down, very, very important, because these things will come in the examination directly in terms of formula. Formula, yes, now we have discussed. I'm just moving towards that particular, the final formula. But before that, we need to develop some fundamental thing. That is what I'm developing in terms of equation. And what will be the angle? That is the angle also we need to calculate, right? What is the angle? Exactly, alpha dash. Then what will be the alpha dash? Tan alpha dash will be Vy divided by Vx. Alpha as well as magnitude, both we can able to find, because velocity got two components, but magnitude as well as direction. Now, for H maximum, that is equal to capital H, what will be the equation of motion? What will be the equation of motion? For H maximum, what about Vy? That will be 0. You know that when it is reaching to the top, then Vy will be 0. Put the value Vy will be 0. Put the value Vy will be 0 in this equation. From this equation, 0 will be u into sine alpha. That will be minus of g into t. Then what we are calculating? How much it is? How much of time will be required to travel the particular height? What will be the answer? U into sine alpha divided by g. Note down, very, very important. This is called time for flight. Time of flight. No, not time of flight. This is called time to reach top of the projectile motion. Top of the projectile path. Very, very important. Note down. Now, once it is done, please let me know. We can discuss about the questions. That means how much of actually time required to reach to the height of the particular, to reach the maximum height in the projectile motion. That is the time. That is what the first answer. Directly objective question will be coming from this, right? Now, what about the next segment we can do? What about the next segment we can do? We can find what will be the total range that will be covered by the particular body. What will be the total range that will be covered for the particular body? That means what is the total distance traveled by the particle from here to when it is landed over here? This particular thing will be called as range. Please note down. This thing will be called as range. Very, very important. Range, and how much time it is taking to complete that range. What will be the answer? What will be the answer? It's a very simple. How much it is? How much time it will require to reach the particular ground level? For completing the range, how much time it is required? And second question is, what will be the maximum height h that you are looking right now? What will be the answer for height? What will be the answer for range? Right? Those are the things that we need to answer, guys. Done? Can I move to the next slide? So today's session is very, very important. Believe me, you will be developing some fundamental thing for basically kinetics. Once you have a fundamental knowledge in kinetics, that particular thing will be useful for theory of machine. That will be useful for machine design also, right? Now, note on the next thing. When I am throwing the ball or particular stone with some velocity u with an angle alpha, it is reaching to the top of the particular height, suppose h maximum, that is what h. How to calculate the h? That is what the next question. You know that s will be equal to ut plus half at square. Apply this thing in the vertical direction. Apply this formula in vertical direction. In vertical direction, what will be the distance traveled by the particle? H maximum. that is equal to h. What about the initial velocity? U naught y into t plus half of ay into t square. Everything is same. I'm just replacing in the vertical direction. H will be what? What about u naught y? What about u naught y? What about u naught y? U into sine alpha. U into sine alpha. And how much time it is taking to reach maximum height? You already calculated or not? You already calculated or not? How much time it is taking time for reaching to the maximum height? You already calculated. What is the answer for that? Time required to reach to the maximum height, the answer is what? U into sine alpha divided by what? Z. Put over here. Put over here. U into sine alpha. U into sine alpha by G. Z by 2. Z by 2. Z by 2. U into sine alpha by G whole square. Then what? If you just rearrange the term, you will be calculating as U naught, or maybe you can take U square sine square alpha divided by 2G. That is the maximum height formula. Note it down. That is what the formula for maximum height that is being traveled by the particle. That is the second answer. Second objective question. First is time. Second is what? This. Note down range calculation. How much range it is traveling, basically covering from starting position to ending position. Starting position to ending position. What will be the range that it is covering? What is the range that it is covering? For range, what we can do, guys? Can I say when h equal to 0, then we can say that whatever the time it will take in this particular formula, if I put s will be equal to ut plus half at square. If I put s equal to 0, or suppose h will be equal to u naught yt plus half of ay into t square, in this particular formula, my dear friend, if I put h equal to 0, so can I calculate t value? That is t for range. How much time it is required to reach the particular height when it is 0? That means when it is touching the ground. Put the value. U into sine alpha time. Now time will become what? Time for range. Now it is what? Minus g by 2 into what? Time for range whole square. Now from this particular formula, what will be the time for range? How much time it will take to complete the particular range, to complete the distance, horizontal distance? What will be the answer? 2 into u sine alpha divided by what? G. Check it out. And that is what equal to what? 2 times of time for maximum height travel. The time for basically finishing the horizontal distance will be 2 times of the time that will be required to particularly what? Complete the height in the vertical direction. Yes, check it out. That is what the next objective question. Third answer. Please check it out, all of you. Understanding or not? Right. Now, once it will be finished, please let me know. Once it will be finished, please let me know. Now, fourth question will be, what will be the range actually? What will be the range actually? That will be the question. For range, can I say, my dear friend, from here itself, apply the same thing in the horizontal direction? Horizontal direction, if I just apply, my dear friend, this particular formula, S will become what? Range or not? Range in the horizontal direction. So this will become u naught into x into time for range. This will be 0. Why? Because ax will be 0, my dear friend. So from here, can we calculate the range? Check it out. Then what will be the range formula? What will be the range formula, my dear friend? U into cos alpha into 2u sin alpha by G. then what we can calculate? What will be the formula for range? Range, we can just check it out. U square sine 2 alpha by G. Please check it out. Sine alpha, 2 sine alpha cos alpha will become sine 2 alpha, right? All of your understanding how we are playing with the equation, Newton's equation. I can directly write the formula, but still within a small span of time, I just want to conclude that how we can derive for each and everything when you strong in fundamental thing. So these are the things that will be required. Now tell me in which condition Ax will not be equal to 0. Under the gravity effect, you know that this motion is what? Under gravity, under the effect of gravity. That's why in the horizontal there will not be any acceleration. But under which condition Ax will not be equal to 0? Anybody can imagine the situation? Simply throwing the ball in the upward direction or inclined direction or in the projectile motion, Ax will be 0. But in which condition Ax will not be equal to 0? And Ay will also be not be equal to 0. Of course, Ay will never be 0 because under the gravity effect, right? But if the body is moving with some initial acceleration, in that case, Ax will not be 0. First of all, before let me just move on to that topic. Let me know once it is finished. This one, right? All of it done? Done, right? Now, try to imagine the situation, my dear friend, where we have the stamp, where we have the structure which is made up of something like this. Try to imagine. What? I'm not understanding. What you're saying? Can you please tell me what you're mentioning? Suppose there is a, we have the structure something like this. Now this is a ball. There is a forcefully we are just throwing the ball from this segment, something like this. There is a structure which is just made. Now this structure is there. You have seen anywhere like we are throwing the ball with some machine. Understanding? There is a machine which is throwing the ball. When you are practicing the cricket, suppose on the pitch, then there is a automatically throwing machine is there, right? Through which the ball is coming to the batsman. Suppose bowler is not available and one machine is there, from that ball is coming automatically to the bat. Understanding or not? Can you imagine the situation? The ball machine. Now, from the ball machine, whatever the ball is coming out, it is got some velocity with some angle alpha. In that case, Ax will not be 0 because it is thrown with some velocity and with some acceleration, my dear friend. Before, we are just simply throwing with our own hand. That's it. And that is what under the influence of gravity. But right now, throwing machine, whatever there, Ax will not be 0. And of course, Ay will also be not equal to 0. Right? So that is a small idea I just want to give. Now, the velocity of projection, you know that velocity with which the particle is projected, that is called velocity of projection. Angle of projection, the angle between the direction of projection and horizontal direction will be called angle of projection. That is what alpha. Trajectory, that is the path traveled by the particle. That is called trajectory. Horizontal range means what? What is the horizontal range? The horizontal distance through which the particle travels in its flight is called horizontal range or simply range of the projectile. What will be the answer for the range? What is the formula for the range? U square into sine 2 alpha divided by g. What you are asking? Sir, but after force is removed, acceleration immediately will not be zero. It will be having some effect. You are throwing with some very, very large amount of force. There will be acceleration. Understanding my point, all of you? All of you are understanding my point? Perfect. The time for flight will be the time duration during which the particle or projectile, whatever the particle will be there in the projectile motion, will be in the motion is called time for flight. Right? So these are the important terms. That is very, very important. All of you have noted down. So at the end of the today's lecture, I will be giving you very important, conclusion. Do not, just leave the class afterwards, because there is an important conclusion will be there. Through that, believe me or not, you will be able to solve GATE 2021 very tough problem. There was a problem in the fluid mechanics that you can able to solve just by knowing static equilibrium equations, right? Now, done all of you? Is it done? Perfect. Now, so the angular motion of a disk is defined by the theta. Try to solve the angular question. We have not solved anything, right? This question, where theta in the radian and t in second. What will be the angular position? See, I just forget to tell you the equation of motion in the rotation also. Whenever any body is doing under rotation, summation of force, V is equal to U plus AT. S will be UT plus half AT square. V square is equal to U square plus 2AS. These are the three equations of motion we have. When acceleration is what? Constant. When acceleration is varying, then we can able to find A will be equal to dV by dt, V will be dx by dt by this particular formula. We can also write omega will be equal to omega naught plus alpha into t in the rotation. Whenever any body is doing what? Rotation motion. S will become theta. Theta will be omega naught into t plus half of alpha t square, where alpha is what? Angular acceleration. Note down, angular acceleration. Angular acceleration. A is what? Linear acceleration, right? But this is for linear motion. These are the formula for angular motion or rotation. The last one will be omega square. That will be omega naught square plus 2 alpha into theta. Please note on this formula, where theta is what? Angular displacement. Theta will be given to you. What about the omega? We know that omega will be d theta by dt. Try to calculate. Try to calculate what will be the answer. When time t equal to what? 2 seconds. Three plus 3t square, right? I'm getting around 15. 15 radian per second I'm getting. But they are not asking omega, they are directly asking what? Theta only. Then what will be the theta? Simply put the value. 6 plus 8, that is what? 14. That will be the radian. 14 radian, that will be the answer. All of you please note down. This question has been asked in CIL. Not done. CIL HL difficulty is almost same. Yes. if you just compare the last 2-year paper, that is 17 and 20, nowadays CIL is recruiting through GATE, but before they used to conduct the examination, almost same level. Now, remaining problem you can solve. Now try to come back to its D'Alembert principle. Note down, we are talking about the kinetics. We are talking about the kinetics. Now we are talking about the kinetics. That means studying the motion, study of motion of particle with the help of forces is called as the branch of the mechanics, that is kinetics. That is subcategories of the dynamics. Here in this one, any object is there. I'm just taking a block. Now you will enjoy the session from here onwards. Try to understand. This is the block which I just placed on the ground. Now you will come to know the difference between statics when the body is in the rest condition and when the body is in the what? Moving condition. There is a small difference, that is what coming. Suppose I am applying the force P. Now there is a friction. Both will be given to you in the problem. Mu(s) and mu(k) will be given to you in the problem. That is coefficient of static friction, coefficient of kinetic friction. Both will be given to you in the problem. The weight of the body that is acting in the downward direction, there will be normal reaction that will be coming because body is what? In contact with the ground and always in contact with the ground. It will never leave the ground. What about the friction force? Whenever the body is acting, the friction force will be acting in this direction. Now there is a trick. And what the trick actually happening in the GATE examination, that is also I'm going to tell you. Now tell me, when the friction force will be less than F, what will happen? When the friction force will be less than F, what is going to happen? No. 3 stages of the friction. 3 stages of the friction. What are all the 3 stages of the friction? Look at very carefully. Very carefully. When this friction force will be less than static friction, right? When the force of friction, or you can just take P, when force P will be less than static friction, what is the Fs? Mu into N. That is a static friction force. Then what will be the values of friction force F? Simply P only. That means under rest condition. Agree with me? Tell me, guys. You know that static friction force is variable. That is being varying from 0 to maximum value, then it is coming down from here. That is what the maximum value, that is mu into N. Right? The moment we keep on increasing the force P, that is maximum value. But before that, any value less than P maximum, whatever the friction force will be there, that is what? Equal to P only. Understanding what I'm taking? The friction force. Small f is what? Friction force. Actual friction force, right? Second condition. If P will be equal to Fs, this is called impending motion. Impending motion. In this case, friction force will become equal to what? Static friction. About to start. This is called about to start motion. If P will be more than static friction, note down, then there is a motion. And whatever the friction force value will be there, that will be kinetic friction value, mu k into N. Is that clear now? The picture is clear by the three different cases. Case number 1, case number 2, case number 3. Is that clear? Check it out. The first A case and the B case we already discussed in the particular friction chapter. Now we are in the third stage. Check it out. All of you, please check it out. And let me know. Let me know, guys. Agree with me? All of you are agree with me with these three particular points which I'm talking about right now? A, B, C, 3 cases. Tell me, guys. I cannot move forward without your reply. This is a very, very important moment. Most of the time, many times, this case B has been repeated in the gate examination multiple times. So it's a very, very important for gate. The case number B. Always they give the point impending motion just about to start. In that case, my dear friend, just put it out this condition, these two conditions, you will be getting the right answer. You will never get a wrong answer. Sorry. Just please note it down. Very, very, very important. Very, very important. Sir, whatever the slide is showing, whatever the slide you are showing right now, that is a D element principle. But you are not talking about that. There is a reason for that. First of all, note down this thing. Then we will talk about the motion condition. Right now we are in the motion. The body is not in the rest condition. The body is start moving. Now, when the bodies start moving, we have to modify ourselves. And how we can modify? In this case, who will be responsible for the motion? Force only. Who will be responsible for the acceleration of the block? Force only, my dear friend, right? When you keep on increasing the force, acceleration will also keep on increasing, right? But the friction force will also be constant. The friction force will always be what? Constant, my dear friend. That is what kinetic friction. That is what kinetic friction, right? Now, once it is done, please let me know. Once it is done, please let me know. Done, right, all of you? Is it done? Perfect. According to Newton's second law, the net force in the direction of motion, will be equal to mass into acceleration. Note down. The net force in the direction of motion will be equal to mass into acceleration. Net force. For this particular block, if I'm just apply the net force in the direction of motion is what? Like this. So P minus friction force, that is kinetic friction, that will be equal to mass into acceleration. This will be the formula. Note it down, very, very important. D-element principle is saying that, you know that what is the static equilibrium conditions? You know that what is the static equilibrium conditions? Summation of forces along the direction of motion must be zero. For maintaining the body to be in the rest condition or uniform motion condition, the net force must be zero. D-element, what it is saying is still you can maintain the body under dynamic equilibrium conditions by just making what? Net force must be equal to zero. But for that, what you do? P minus Fk minus Fma, that must be equal to zero. So it will look just like what? The net force under dynamic equilibrium condition that is equal to 0. That is what the statement. Where R is what? R is nothing but resultant forces, my different. Net resultant forces minus MA, that will be equal to 0. Understanding? So it is looking like this condition or not? This is the condition for static equilibrium conditions. We are maintaining the body even under the motion, but we are maintaining what? Dynamic equilibrium conditions by applying some one pseudo force. That pseudo force we call MA in the opposite direction. I should not call this to be pseudo force because there is nothing called pseudo force. We talk about the pseudo force when we talk about the non-inertial frame. Of course, I'm not going to talk in detail about those things because that will be covered in detail in the GATE course, right? Right now, we are not going to discuss those things. Just try to remember that for maintaining the body under dynamic equilibrium conditions, we need to apply one more force MA in the opposite direction, like this. P minus MA minus F will be equal to 0. Understanding? Tell me, guys. Look at this statement. The D'Alembert principle looks at the above equation as the equation for equilibrium and states that the system of forces acting on a body in motion will be under dynamic equilibrium condition with the inertia force of the body. This is called what? Inertia force. Understanding? Tell me, guys. Perfect. Please note down these things. Very, very important. Note down all the things that are very, very important. So for the linear motion, you know that the net force must be equal to mass into acceleration. But what happens when the body is doing angular motion? What happens when the body is doing angular motion? In that case, net torque will be equal to I alpha. Yes or no, guys? Tell me, guys. Are you understanding what I'm talking about? The net torque must be equal to I alpha. Can you please hear me? All of you. All of you are understanding what I'm talking about? Tell me, guys. When the body is doing linear motion, the net force must be equal to MA. But when the body is doing angular motion, the net torque must be equal to I alpha, right? Can I move to the next slide? When we solve the numerical one problem, the things will be clarified, definitely. Right? Now try to look at the problem that has been asked in CGPSC assistant engineer. There is a two block which is being connected by the light cord which is passing over a smooth frictionless pulley. There's a pulley through which block 50 Newton, and there is a one block that has been there 100 Newton, which has been placed something like this. They are asking what should be the acceleration and tension in the particular string that has been connected over the pulley. This pulley is what? Frictionless pulley. This pulley is what? Frictionless. Frictionless pulley. That means whatever the tension will be there in both the string will be same, because if there is no friction, will be smooth. Whatever the tension will be there, same tension will transfer to this particular string also, left string. Now, this is a very good problem for the dynamics that we can able to solve. So all of you want to try for 1 minute? All of you want to try for 1 minute? Let me know. Tell me, guys. There is a method that I will discuss. Follow that method. You can solve any number of problem, whatever the number of pulleys that has been attached to the string. Before that, let me know. All of you are understanding the problem or not, at least. Perfect. Now try to solve it. Try to solve it. Apply Newton's second law of motion. Apply Newton's second law of motion. First of all, you need to understand, my dear friend, how the motion is happening. How the motion is happening. Now, try to just take the body 100 Newton and 50 Newton. Just tell me which one is the heavier one, 50 Newton or 100 Newton. 100 Newton is what? Heavier one. So definitely the motion will be there for this one in the downward direction. What about the motion for 50 Newton? If it is moving in the downward direction, automatically it will move in the upward direction. Am I right? Check it out. the direction of motion for 100 Newton will be like this, and direction of motion for 50 Newton will be like this. Check it out. All of you, please check it out. Perfect. Try to draw the free body diagram for 100 Newton. The weight of the body that has been acting in the downward direction. The tension force that has been developed will be something like this. The tension force that has been developed will be something like this. Now, the direction of motion is what? Like this. Apply Newton's second law. The net force in the direction of motion must be equal to mass into acceleration. Net force in the direction of motion under Newton, positive or negative? Positive or negative? Positive or negative? Positive. In the direction of motion, positive. T is in the opposite direction of motion, negative, my dear friend. What about the mass? Weight is what? mg. That has been given 100 Newton. Now, if you want to calculate mass, you can just calculate 100 divided by g. That has been there in the kg, my dear friend. That is the first equation. I got it. Apply the free body diagram for 50 Newton block. It is moving in the what? In the upper direction. The weight is acting in the downward direction. The tension is acting in the upper direction. Apply Newton's second law. The net force in the direction of motion must be equal to mass into acceleration. Mass into acceleration. So T minus 50, that will be 50 by G into A. Check it out. Please check it out. Now, some of you might be thinking, sir, two blocks are there, block A and block B. But why you are considering for block B and block A acceleration to be same? A only I am considering. What's the reason for that? My dear friend, the tension force for both the block is same. Whenever the force is same, the acceleration must be same. If the tension would have been different, the acceleration would have been different. Understanding my point? Are you getting my point or not? This is a very fundamental thing. A lot of problems already been asked over this question from this particular section. Check it out. If some of you are not understanding, please let me know. Getting my point? Check it out. Please check it out. You know that two equations we have and two unknowns we have. Two equations and two unknowns we have. You can easily and comfortably able to solve it. Two equations, two unknowns. Everybody able to solve it. I believe that. If not, let me solve that. So just multiply with this thing with the two things. 2t minus 100 multiply with the what? 2. That will be equal to 100 by g into acceleration. Now what you can do, by equation 1 and by equation 3, by equation 1 and equation 3, you can able to solve minus 100 plus 2t, that is equal to 100 by g into acceleration. Now what you do? Now what you do? Subtract it, or basically what? Just add it. What you will be getting? 200 by g into acceleration. T will be what? 200 by g into what? Acceleration. Put the value of t. Put the value of t in any equation. You can calculate what? T minus 50, that is 50 by g into acceleration. T is what? 200 by g minus 50g total acceleration, that is equal to what? 50. Then what is the acceleration from this equation? 15 to g divided by 150. Then what you are calculating? G by 3. Once you got g by 3, what about tension? 200 by g into g by 3. That is 66.67 Newton. Please check it out. All of you. All of you are understanding my point or not? If anybody not understanding Newton's second law, please let me know. Very, very fundamental thing. Very, very fundamental thing. Check it out, guys. I'm not getting reply whether you are understanding or not. All of you are understanding or not this particular problem. You know one equation, T1 by T2, that is equal to e to the power mu theta. How many of you know this equation? Whenever there is a friction in the pulley, Whenever there is a friction in the pulley, this is the equation for tension in the tension side and slack side. Anybody know this equation? Let me know. Tell me, guys. Please reply, guys. I don't know whether you are understanding or not, but I'm trying my level best from the basic to scratch and all kinds of stuff. That is what I'm doing. Pulley friction problem. Now you learn in the machine design. Now friction is zero. Pulley friction is what? Frictionless. Mu is zero. This is zero. E to the power 0, 1. That's why T1 equal to T2. That's why T1 equal to T2. Some of you might be having doubt. That also got clear. Pulley friction. The rope has been passing through a pulley. The rope has been passing over the pulley. There is a rubbing action. There might be friction. For that, there is a formula T1 to T2. But if that is 0, e to the power 0, that is equal to 1. That's why T1 equal to T2. And that is what I have taken T. When T is same, force is same, nobody can stop to have the acceleration for both the block to be same. That's why we got single acceleration. If T1 and T2 would have been there, then there might be two acceleration, AB and AA. AB and AA. There might be two acceleration, but right now, both will be same. Done. Can I move to the next thing? Acceleration, which one? Where? Which step or which equation? Which one you are talking about? Tell me, guys. Prabhakar. GB by 3. I'm not getting my your point, what you are talking about. Can you please repeat once? Acceleration part, you are saying which one? Acceleration will be same when the force will be same in both the block. When the force will be different, tension will be different, the acceleration will also be different. Right? Can I move to the next thing? Perfect. Thank you. Now try to solve this question. Not only this one, many time in the other PSU also. Other PSUs, many times this question has been repeated. Many times. So the tension in the cable supporting a lift. There is a lift. There is a lift, my dear friend. The lift is going to have some mass. Now it has been supported by the cable. In the cable, there might be tension. In the cable, there might be tension. Now it is moving in the upward direction in the first case. In the case number 1, it is moving in the upward direction. The motion is what? In the upward direction. In the upward direction. The motion is what? In the upward direction. The tension in the cable supporting a lift moving upward direction is twice the tension. I'm just taking T1 when it is moving in the upward direction. Now T1 is what? Twice the tension when it is moving in the downward direction. This has been given in the problem. mg T2, this is case 2, when it is moving in the what? Motion is happening in the downward direction. What they are asking, what is the acceleration of the lift will be equal to? They are asking what should be the acceleration, my dear friend, for this particular question. Tell me, guys. That means even though we have right now the different tensions, they are asking the common acceleration of the lift. They are asking, right? The common acceleration of the lift they are asking. In the first case, in the case number 1, the motion is happening in the upward direction. Newton's second law is saying that net force in the direction of motion must be equal to what? Mass into acceleration. T1 minus mg, that will be equal to ma. That is the first equation. For case 2, the net force must be equal to mass into acceleration, that is in the downward direction, is positive. Here it is upward direction, positive. mg minus T2, that is equal to mass into acceleration. That is equal to mass into acceleration. Now in this case, what will happen? In this case, what will happen? T1 is what? 2 times of T2. T1 is what? 2 times of T2. Now in this case, what I can put? What I can put? mg minus, or yeah, from equation number 1. From equation number 1, 2T2 minus mg will be equal to ma. This is my third equation. From equation 3 and from equation number, what you can say second, from equation 3 and from equation 2, what you can have? Minus T2 plus mg, that is equal to ma. Multiply with the 2, multiply with the 2, multiply with the 2, and just add it. What you can get? 3 ma. This will cancel out, so acceleration will be g by 3. Check it out. All of you are understanding? So this question has been asked in Tamil Nadu Public Service Commission and Vizag Steel, 2017. Right? All of you are getting my point? All of you are getting my point? Tell me, guys. Correct. Once we got it, please let me know. Once it is done, please let me know. Is it done? Can I move to the next segment? Can I move to the next segment? Perfect. Perfect. Note down the work energy method. Note down the work energy method. Note down the work energy method. How many of you know about this work energy theorem? How many of you know about this work energy theorem? How many of you know about this work energy theorem, guys? Very, very important. Work energy theorem, how we can derive this particular work energy theorem? That is also very, very important. How we are able to derive this particular equation? Yes. The total work done must be equal to change in kinetic energy. But how it is possible? Anybody having any proof? Tell me, guys. Very, very important section we are right now. Tell me, guys. If you know something about this, please let me know. Very, very important section. Yes, please. You know that force equal to mass into acceleration. Am I right? Tell me, guys. Net force will be equal to what? Mass into acceleration. My different force I can write, this force I can write m into dv by dt. What I'm doing, dx by dx, I'm just multiplying, so that I will be getting what? Mass into dv by dx. Dx by dt is what? V. Force into dx, that is equal to what? Mass into v into dv. What is the work done? What is the work done? You know that force into displacement, force into distance, what we call work done. In the vector format, what we can write? F into x what? Cos theta. Simply work done we can write F dot x. Note down. Work done will be what? Tell me guys. How much amount of energy will be consumed to displace the body from one position to other position? That is called what? Work done. Right? That is called energy. What is the unit? Joule we have. Newton meter. Check it out. Now what I'm doing, I'm just doing the integration. Force into dx is what? Total work done. Total work done. That is equal to what? M into V square by 2 from initial to final. From initial to final. Then what we can have? M by 2 Vf square Vi square. You know that the kinetic energy is what? Half of mv square. So what we can write? Final kinetic energy minus initial kinetic energy. Yes or no? Got the proof? Got the proof, my dear friend? All of you? Perfect. Note it down. Very, very important. Total work done. Now tell me the work done can be, how many types of work done you can have? How many types of work done you can have? Conservative work, non-conservative forces work. Conservative force work, non-conservative force work. What do you mean by the conservative? What do you mean by non-conservative, my dear friend? All of you, please let me know. What do you mean by the conservative or what do you mean by the non-conservative? That's a very, very important section. Conservative and non-conservative. Shall we discuss in the next slide? Can we discuss in the next slide? Perfect. No. Sorry. Note down. Important note. The conservative forces we call conservative forces will be conservative means which does not depend on the path, just like a spring force, gravity force. They do not depend on the what? Path. They depend on the end point. That's it. Non-conservative forces, can I say friction force? Which depends on the path. Which depends on the path. Let me know, guys. Conservative force will be spring force and the gravity force. Non-conservative force will be what? Friction force. According to work energy theory, summation of all the work done must be equal to change in kinetic energy. Must be equal to change in kinetic energy. What about all the work done? What do you mean by all the work done? Work done by spring, work done by spring force, work done by gravity force, work done by friction force. That will be equal to change in kinetic energy. Please note it down. Now I will ask you the question about spring energy. What is the work done by spring force? Tell me, guys, what will be the formula? What will be the formula for work done by spring force? You know that work done by spring force will be force into x into dx. Force, spring force into dx from initial position to final position. What is the spring force you have, my dear friend? What is the spring force you have? Spring force, you know that minus k into x. Yes or no, guys? Whether it's clear or not, fundamental things. Whether fundamental things are clear or not. So can I write half of k xi square minus xf square, where k is nothing but stiffness of the spring. All of you are understanding, or I'm moving very fast? Let me know, guys. Because some of you might be doing mistake in writing the work done of the spring something like half of k x final minus x initial, but that is wrong. This is correct. Let me write the work done by gravity force. That is also equal to minus of mg into dy from y1 to y2. So whenever you want to write mg into, you just write y1 minus y2. That is correct method. Please note down, very, very important. Very, very important. In fact, sometimes we used to call work done will be the net force in the direction of motion into distance. This is the exact formula, my dear friend. This is the exact formula. The net force into distance. That is what the total work done we have. Understanding, all of you? This is the most generalized way I'm discussing right now. The work energy theorem. That is a very, very important theorem. Most of the problem you will be able to solve by this particular theorem. Work energy theorem. Right? Newton's second law, work energy theorem, impulse momentum theorem. 3 theorems we have. In the end also, I will discuss the conclusion when to use these particular three theories. Right? Done, all of you? Is it done? Can I move on to the question that we can discuss about this thing? Perfect. Perfect. Now, my dear friend, work done by spring force, because you know that total work done, total work done must be change in kinetic energy. That is what the theorem that is said. Work done by, gravity force plus work done by friction force. That is equal to half of m into v square minus u square. Final kinetic energy minus initial kinetic energy. What is the work done by spring force? Half of k x1 square minus x2 square. Work done by gravity force will be mg into y1 minus y2, where y1 is what? Suppose any object is there, you are taking from, suppose this body you are taking from y1 to y2 at this position from the reference. This is my reference point. You are taking the body from this position to this position. Now what will happen? What will happen, guys? What will happen? Potential energy will increase or decrease? Potential energy will increase or decrease? Potential energy will increase or decrease? Now, that we will solve by using the formula. Do not worry. My dear friend, if work done by friction, if there is no friction is there, then what we can say, coming, whatever coming, that is what going out. Whatever coming, that is what going out. And this is called conservation of mechanical energy. Are you understanding the conservation of mechanical energy and the difference between work energy theory? Sometimes they used to say both are same, but that is not same. When work done by friction is zero, then only we can say that the mechanical energy is being conserved. If there is a friction, mechanical energy will not be conserved. It will be converted in the form of what? Heat, and that will be gone. Some part will be gone. And this is called conservation of mechanical energy. Note down, guys, very, very important. Some of the kinetic energy, potential energy will always be what? Constant. Very, very important. Whatever the initial kinetic energy and final kinetic energy will be there, and whatever the summation of kinetic energy and potential energy, initial, the final will also be same. The final will also be same, my dear friend. Note it down. Very, very important. Is it done? Is it done? Once we solve the numerical, the things will be clarified. Now you should know the difference between work energy theory and conservation of mechanical energy. Both are different things. Both are not same thing. When friction force will be zero, then only both will be what? Same thing. Now, so here we have got the question. Before that, just note on the, suppose this is the question number 1 from work energy theory. Note on the question number 2, which I am just talking about right now. Now there is a block. Yes, what I can take. What I can just have, just wait. Yes. There is a block. I'm moving with some velocity u naught, or let's suppose that u is not equal to 0. U which is not equal to 0. I'm moving with some initial velocity u. I'm just taking to this particular part from here to here. From here to here. This is my final position. This is my initial position. Suppose that. And the height is what? Suppose that h height is there. They are asking what is the height in terms of velocity. They are asking what is the height in terms of velocity. Now, there is a no drag force. I'm not considering any drag force. That means there is no friction force. There is no air friction force. Suppose that. So can I apply the conservation of mechanical energy? Suppose there is no friction, there is no drag force. Then can we apply conservation of mechanical energy over here? Initial kinetic energy, initial potential energy, that must be equal to final kinetic energy plus final potential energy. Check it out. What is the initial kinetic energy? What is the initial kinetic energy? Half of mu square. What about the initial potential energy? If I'm taking this particular reference, if I'm taking this reference, tell me what will be the potential energy? Is it at the ground level? 0. What about the final kinetic energy? When anything, if you're just throwing to the in the vertical direction, any ball, when you're taking and throwing in the vertical direction, maximum height of the building, suppose that you're throwing ball from here to here, then what will happen? The top of the block, the top of the building, the velocity will be what? The final velocity will be what? Become 0. Yes or no, guys? At the end, for some moment, it will become what? Under rest condition. While reaching to the top of the building. And that is what the final kinetic energy will be what? 0. What about the potential energy? Mg into h. Then what we can have? Velocity. Then what we can have the velocity? Can I say 2gh under root? Check it out. Please check it out. All of you, please check it out. Perfect. Now, some of you we will say that, sir, I'm not taking this reference, I'm taking this reference. I'm taking the reference number 2. This is for reference number 1 discussion. Suppose somebody is very much interested, for them I'm just explaining for reference number 2, because potential energy and spring energy will depend on the reference, which reference you are taking. Suppose you are taking 0 level over here. Now for this case, what will be the initial kinetic energy, initial potential energy, and what will be the final kinetic energy, and what will be the final potential energy? Remember, potential energy means what? Spring force energy as well as what? Gravity energy. Initial kinetic energy, what we can have? 0. 0. Yes or no, guys? What about the final initial potential energy? What is the final kinetic energy? Half of mu square. Half of mu square. What we can have? What is the initial kinetic energy, initial potential energy and final potential energy? Let me know. If you are taking the reference from here to here, then what we can have? 0. Yes or no, guys? You are taking at the reference point, the ground level point, something like this only, 0 only. But right now, the final position is what? In the downward direction. Final position is what? In the downward direction. Potential energy will increase or decrease? Potential energy will increase or decrease? Increase or decrease? Decreases, my dear friend. So from here also you are getting same thing. Suppose somebody is very much interested, sir, no, I'm going to follow total work done will be equal to change in kinetic energy. Suppose that somebody is very much interested to know the total work done will be change in kinetic energy. I don't want to follow, sir, any other thing. I don't want to understand this conservation of mechanical energy. I just want to follow work energy theory. Through that also you will be getting same answer, my different. How? Look at over here. Change in kinetic energy will be what? V square minus U square. Work done by what? There is only gravity force is present. And what is the gravity force work done? H1 minus H2. H1 minus H2, my dear friend. Or what we can have? Y1 minus Y2. Rather to say H1 minus H2, you can have Y1 minus Y2. Try to understand. Try to understand. What we can have from here? What we can have from here? H1, you are taking from the ground level. You are taking from the ground level, suppose, and that is what the formula has been derived. That is what the formula has been derived or not? Work done by gravity force has been derived mg into y1 minus y2 while taking the reference from the ground. What is the initial y1? 0. What is the final y2? H. What is the final velocity? 0. What is the initial velocity? U. Minus half of mu square minus of mg into h. Are you getting same thing or not? So now it is verified whether conservation of mechanical energy and the work energy theorem both are same thing, right? So you have many methods. Once you have the fundamental clarity, you can play with the topics. Again, I'm saying once again, you and I will prove that also. Whatever the GATE 2022 problem is there, you will come to know the importance of the first chapter that we discussed, that is static equilibrium equations. That you will understand. Done, all of you? Is it done? Whether you got the clarity about the this work energy theorem as well as conservation of mechanical energy? Perfect. Thank you. Now try to understand the momentum. Before that, I would like to tell you about, some of the few questions. Try to solve this question. What will be the solution? Wheel having a mass. This problem will be better to solve after the center of gravity and moment of inertia calculation. This question will be very good thing to solve after moment of inertia, right? Now try to solve this question. Is it done, all of you? Are you getting any answer from for this particular question? Any answer? Very, very important. A block is there, which are just plane or inclined plane. Now this block is moving in the what? Upward direction. The motion is what? In this direction. Up the plane. The motion is up the plane. Now it is being traveled the distance from here to here. The distance has been traveled is what? 1.6 meter. What is the theta value? 45 degree, my dear friend. What they are asking, what is the total work done? They are asking what is the work done. If I draw the free body diagram, my dear friend, of the block, the weight is acting in the what? In the downward direction. This component will be mg into cos theta. This component will be mg into sin theta. There will be normal force and there is a friction force. Friction force will be acting in the what? Opposite to the direction of motion, something like this, right? Will be acting in the opposite direction like this. Now, whenever there is a motion, work done means there is a motion. When the motion has been started, my dear friend, that is a kinetic friction or a static friction? Kinetic friction or a static friction? Kinetic friction. You know that the work done will be net force in the direction of motion into distance. This is what the formula for the work done. What is the net force in the direction of motion? What is the net force in the direction of motion? The motion is what? In this direction. The motion is what? In this direction. Then what about the forces that is acting in this direction, opposite direction? Then what is the value? Minus of mg sine theta plus friction force. Check it out. All of you, please check it out. All of you, please check it out. Now, summation of forces along the y direction. Summation of forces along the y direction is 0 because there is no acceleration. In this y direction, acceleration is 0. Then what will be the normal reaction forces? Mg cos theta. That you got one thing. Then friction force will be what? Mu k into n. Put over there and tell me the answer. Put over there and tell me the answer. Tell me guys, what will be the answer? Now just forget about the negative sign, just try to calculate the magnitude. Then what will be the answer? 500 sine 45 plus mu k 0.25 into 500 into cos 45, right? Now if you just calculate the force, what you will be calculating? The force value will come out to be 500 1 upon root 2 into 1.25. Now you multiply with the basically what? Distance 1.6, that you are calculating what? Total work done. What is the total work done are you getting? Are you getting the answer as 500 into root 2? Check it out. Are you getting this particular answer? Check it out, guys. Are you getting the answer? Perfect. This is the Newton meter. That will be the answer. Is it done? All of you, is it done? Suppose if I would have not told you about that net force, the net force in the direction of motion, you would have only considered mg sin theta. If I just told you about the force into distance, you might have think only mg sin theta. No, the total force, right, in the direction of motion. But there is no force in the direction of motion. There is no force in the direction of motion, or the forces are opposite to the direction of motion. That is what negative answer, right? Now we can discuss about the impulse momentum theorem. Once it is done, please let me know. Done? Perfect. Thank you. Note on the impulse momentum theorem. Impulse momentum theorem. It's also very similar. Force is equal to what? M into acceleration, that we can write m into dv by dt. Force into dt, that is equal to what? M into dv. Now if you integrate force into t, m into what? V minus u. For a very, very small amount of time, how much of force that is acting? That is called what? Momentum. If somebody will ask you what is the impulse, what is the momentum, then you must say, if you just want to find the impulse, then what is the formula? Final momentum minus initial momentum, right? Please note down. This particular term is called as impulse. Impulse means The amount of force that is acting for a very, very small duration of time, that is called what? Impulse. And that is what the formula we have. Final momentum minus initial momentum. Do not confuse. Don't say initial minus final. No. Final momentum minus initial momentum. So at the end of the engineering mechanics course, we got the development of each and everything. Now you can play with the subject. You can take any book. You can solve any number of problem. You will be able to solve that problem. If not, send me on WhatsApp. We'll be having the discussion on that, right? In fact, just note down net force into time will be equal to m into v minus u. Final velocity minus initial velocity. What happens when the net force will be zero? When the net force on the body is zero, when the net force acting on a body is zero, then what will happen? Anybody will responsible for change in momentum? See, force only will be responsible for change in momentum. Suppose any body is moving, you just try to disturb with the force, then what will happen? Velocity will change, momentum will change, and change in momentum, impulse will be coming. Understanding or not? Apart from it, any other thing, any other sources will be there to basically change the momentum of the body apart from the forces. You know that when the force is zero, dv will be zero, acceleration will be zero, right? So there will not be any source other than this force who will be responsible for changing the velocity, right? When there is a no change in velocity, then momentum will not be there, right? And this system we call conservation of momentum. Understanding or not? Conservation of linear momentum. Please tell me, guys. All of you are understanding what we are talking about? Yes? Hello, hello. When the net force on the system is zero, again, somebody will ask me, sir, why you're not writing only force into T? That is there in the very low standard textbook. If you just follow high standard textbook, they will use to write net force into time must be equal to mass into what? Change in velocity. Right? All the forces must be zero. The net force must be zero on the system. Then only we can say that the momentum is what? Conserve, my dear friend. That is what conservation of momentum we have. Now, done this slide. And what will be the unit? Newton second. What will be the unit? Newton second. Is it done, all of you? Perfect. Note down impact of elastic bodies. Whenever two bodies are there, body is moving with some velocity u1 and body 2 is moving with some velocity u2. After colliding with each other, suppose they are colliding, after that they can be anything, velocity v1 and velocity v2, body 1, body 2. Suppose both the bodies are colliding with each other, there are three types of impact will be there. The first impact we call elastic impact. We call perfectly elastic impact. What do you mean by perfectly elastic in plastic? Anybody know the example? Anybody know the example? Perfectly elastic impacts. Perfectly elastic impact. Can I tell you example? A ball is there, which is being thrown with some velocity u. It is just striking the ball, and after striking, it is just coming back with some velocity v. This is the example of the perfectly elastic impact. Understanding my point? All of you are understanding? All of you are understanding? The perfectly elastic impact will be any ball which is just striking the ball, and it is coming back. That is the elastic impact, right? That is the elastic impact. What do you mean by elastic impact? note down, the meaning of elastic impact will be the 100% of the kinetic energy, 100% of the kinetic energy is recovered after impact. What do you mean by this? Whatever the kinetic energy is, initial kinetic energy, the same kinetic energy will be there after striking also. There is a no loss in the what kinetic energy. Whatever the body A is there, whatever the kinetic energy of the body A is there, the same kinetic energy will be there after striking the ball also. That means whenever we have the elastic impact, two things are there. Momentum is conserved, and second thing will be kinetic energy will be conserved. That means initial momentum will be equal to what? Final momentum. Initial momentum will be equal to final momentum. Now some of you might be asking, sir, what about those formula F into dt that is equal to m into v minus u? Now tell me, any force is acting, whether you are pulling or pushing this block or this particular ball with some velocity with some force? Nothing, right? Yes or no, guys? Initial momentum will be equal to what? Final momentum, because net force in this system is what? 0. That momentum is what? Conserved. So just note down m1 u1 plus m2 u2, that is equal to what? m1 v1 plus m2 u2, m2 v2, where m1 is what? The mass of the block 1 or the ball 1, and what? Second object I am taking what? This particular ball. Ball initial velocity and final velocity is what? 0. Both are 0. But what about the initial velocity of the particular thing? This is 0. This is going to be 0. Then this thing will be there, the mass 1, mass 2. Then u1 will be equal to what? V1. When u1 is equal to what? V1, my dear friend. That is V1 is what? What about the V1? U1 is what? Initial kinetic energy of the ball. Initial velocity of the ball. What about the V1? The final velocity of the ball. What about U2? Initial velocity of the ball and final velocity of the ball. What about the V1? Final velocity of the ball, and U1 is what? Initial velocity of the ball. When initial velocity and final velocities are same, can we say initial kinetic energy will also be equal to final kinetic energy for the ball? Hence, momentum is what? Conserved, as well as kinetic energy is also conserved. Yes or no, guys? Check it out. Do check it out. Please verify it. Please verify it, all of you. All of you, please verify it. Correct? Now, for such a type of system, we define coefficient of restitution. What is the meaning of coefficient of restitution? Note down. It is a ratio of, it is defined by E. It is a ratio of velocity of separation, the relative velocity of separation, divided by relative velocity of approach. What is the relative velocity? The difference between the final velocity, difference between the initial velocity. That is what we have from this particular formula. What is the perfectly elastic body? What about this case? E value. Tell me the E value. 1 or not? Check it out. Check it out. V2 is 0, U2 is 0. Put the value. V2 is 0. V1 is what? Again same as U1. U1 is what? U1 only. And again U2 is 0. Right? What we have? -1. Now if you just take the magnitude, it is what? 1 only. Yes or no, guys? Please check it out. All of you, please check it out. Always try to calculate this thing in mod. Always try to calculate this thing in the what? Mod. Remember, E value cannot be negative. E values varies from 0 to 1. It cannot be negative. So anyhow, you try to manage the formula in such a way that always you get positive value, right? That's basically the method. Not done. Can we discuss about the second impact? Perfect. Now let me talk about the second impact. Let me talk about the second impact. This is called as perfectly plastic impact. What about the example? Any bullet is there. Any bullet is there. Now bullet is what? The bullet is what? It is just riding over this particular bullet is just striking the vehicle. Object 1, and this is what we have object 2. The moment it is got some initial velocity, let's suppose that u. The block is also having some velocity, let's suppose that v. Right? Now, after striking, what will happen? It is just embedded this particular thing. Suppose that the bullet is not coming out of this cart. Suppose this is a cart. The bullet is striking the cart. After striking, the bullet is not coming out of the what? This particular cart. Then what we can say? Then what we can say under this condition? Tell me, guys. Whatever the initial kinetic energy is there, the total kinetic energy has been there in deformation only. Yes or no, guys? Because when it is going to embed, when it is going to deform, yes or no, guys? Deform this particular card, then only it is going to enter, and all the kinetic energy will be just gone in the what? Deformation only. So here what we can have? 100% of the kinetic energy will be gone to deformation only. Whatever the final kinetic energy will be there, that is absolutely what? Zero, my dear friend. Understanding my point? Check it out. Check it out, guys. 100% of the final kinetic energy will be there. That will be what? Final kinetic energy will be lost in deforming the system, in deformations. Now, in this case, what we can have? Conservation of momentum. Apply by conservation of momentum. By conservation of momentum, m1, mass of the bullet, it is moving with some velocity u. Mass of the cart, it is moving with some velocity, suppose u2. After that, it is just suppose that the cart is moving, then what will be the velocity of cart and block? This bullet. What about the velocity? Will be same or different? Suppose it is get embedded into the cart, it is just attached with the cart. Then what will be the final velocity? Will be same for both bullet and cart or not? So can I say m1 plus m2 into v final? That means whatever the final energy will be there for block as well as cart, that is equal to what? Vf only. Check it out. Please check it out. Conservation of momentum, whether it is clear or not. Initial momentum, that is equal to final momentum. Please check it out. When the bullet and cart will be embedded to each other, they cannot have the separate velocity. See, before elastic impact, the ball is just impacting with the wall. It is coming out from the wall. After impacting, it is bouncing back. So initial, whatever the velocity is there, that is what the final velocity for this particular block, for this particular ball. But here the situation is different. It is not getting just attached. It is not just coming out from the bullet. Suppose that this system is there, the bullet is there, and the cart is there. After impacting, the bullet is what? Coming out with some another velocity. Suppose v1, and this final velocity of the cart is what? The final velocity of the cart is what? v1. Then we can say, suppose that v2. Then we can say that the things are different. Yes or no, guys? But right now, due to plastic impact, it is just getting attached with the system only, the cart only. So both cannot have the separate velocity. Both will have what? Same velocity only. Now in this case, what about E value? v2 minus v1, u1 minus u2. v2, see, remember v means what? Final velocity for individual. U means what? Initial. Just try to have the understanding of these symbols. V2 minus V1, there is no difference. So E will be what? 0. Directly they are asking in the examination, what will be the coefficient of restitution? What will be the coefficient of restitution for perfectly plastic impact bodies? Understanding or not, all of you? Note down the last third impact, semi-elastic impact. This one, I'm talking about this scenario, semi-elastic impact. In this case, E value can have from 0 to 1. It may be 0.75, 0.25, anything is possible, right? It's something like that. Ball 1 and ball 2. This is the ball number 1, ball number 2. Suppose after striking, they will be coming out to be with some different velocity. It may be possible that it is moving with some very, very high velocity than this, but after that, it is just become slower than this one because it is transferring its kinetic energy to the ball 1 to 2. So ball 1 after the striking, after colliding, the velocity might be decreased, and what will happen? What we can have? The kinetic energy can also be decreased. That is some type of what? Semi-elastic bodies, semi-elastic impacts or collides. Done. Is it done, all of you? So more 5 minutes I will take the class to just discuss about the center of gravity and moment of inertia, because that is very, very important. Very, very important. Now, so the last chapter for this engineering mechanics will be center of gravity and moment of inertia. Done, all of you? Is it done? So what are the topics that we covered? First of all, we covered the kinetics. If I just talk about the today's topic, kinetics we have covered. We have covered work done. We have covered work energy theory, then conservation of mechanical energy, and then we have covered what is the momentum? What is the meaning of momentum? If I just ask you what is the momentum, what you will answer? M into V. Mass into velocity, that will be momentum. Understanding? If somebody will ask you the unit, kilogram meter per second. Remember. Then we come to know what is the meaning of impulse momentum theorem, and then we got to know what is the conservation of momentum. Right? Conservation of linear momentum. Understanding? Done. Now down the last topic, centroid and moment of inertia. Centroid and moment of inertia. Any object is there. What do you mean by the centroid and center of gravity, and what are the difference? What do you mean by centroid, center of gravity, and moment of inertia? We will just discuss the formula. Do not worry. We will just discuss about the formula. That's it. What do you understand with the centroid? Why we are able to? Why we are very much interested to find the centroid of any body? Tell me. Yes, please. Fast, so that we can wrap up the session. See, if somebody will ask you the definition, what you can write? What you can write? It is a point in an area about which the resultant moment of the whole area is 0. It is a point. See, suppose we want to collapse any big building. Try to find the centroid of that building or center of gravity of that building. And about that, you just apply the force, the building will collapse. That is the beauty of the center of gravity. Then what is the difference between centroid and center of gravity? Centroid is valid for plane area, for 2D. And this is center of gravity for human body, 3D figure. It is a point about which, it is a point in a plane area It is a point in an area, about which the resultant moment of the whole area will become 0, right? And what is the formula to calculate? Y bar, if suppose any object is there, if you want to calculate the centroid, this is the bar, which is having the width, suppose B, and height is what, H. This is the reference X and Y axis. Now somebody will ask you to calculate the centroid for this particular plane area. Then what you will say? Sir, Y bar will be exactly at the midpoint at a distance H by 2 and exactly at the B by 2. So this will be the centroid for this particular, plane area. And suppose multiple bodies are being connected, then how to find Y bar? How to find Y bar? Summation of A, Y bar, sorry. Let me write separately. Already it is being written. Summation of AI, YI divided by what? Summation of AI. Note down, we will come to know through problem. Similarly, we can find X bar also by this particular formula. Remember, it is valid for area. Center of gravity, we are calculating for what? 3D figure. Here the formula will be weight. What will be the weight? Instead of area, volume will be coming. Summation of VI, YI divided by summation of VI, where V is what? Volume. Very, very important. Because what is the weight? M into G. What is the mass? Volume into density. Suppose it is made up of same density, then we can have what? Volume only, because density will cancel out from numerator and denominator, right? Are you getting my point? Is it done? Is it done, guys? All of you? Perfect. Thank you. Now note down the sum of the centroid for common figure. For triangle, if you just take the reference point from here for the triangle x-axis and y-axis, remember the axis also, very, very important. So x bar will be what? What about the x bar? What about the x bar? Suppose it is unsymmetric. Suppose it is unsymmetric figure, x bar we will calculate. What about the y bar? H by 3. Y bar will be H by 3. What about the area? Half of base into height. What about the semicircle? Semicircle is there. The y-axis is there and x-axis is there. Now I want to calculate the x bar. How to calculate the x bar? How to calculate the x bar? X bar we are calculating from y-axis. Now it is symmetric. If it is symmetric, x bar will be exactly on the y-axis or not? X bar will be exactly on the y-axis or not? See guys, when you take something like this, then x bar will be something like this. That is equal to radius. But when you take the y-axis from there itself, then what about the centroid? X bar, 0 or not? Check it out. Please check it out. X bar will be 0 for symmetric figure. For symmetric object, X bar will be 0. And what about the Y bar? Y bar we are taking from the x-axis. Y bar we are taking from x-axis, that is what? 4r by 3 pi. Suppose this formula you want to know, sir, from where we derived, that has been discussed in what? In detail in the GATE course, right? That is what going to start. Already started, but technical subject will start in a few days. An area, of course, pi r square by 2. Quarter circle, if there is a quarter circle, you know that you can able to calculate from here. It is 4r by 3 pi. And from here also it's a 4r by 3 pi. Here it will be central, right? If there is a sector of arc, again it is what? Symmetric about x-axis, y bar will be 0. It is symmetric about y-axis, x bar will be 0. Understand this thing. And again, x bar we can have the formula like this. If there is a parabola, something like this, of course this is not required. You can leave for this one. These are the very, very most important thing. Similarly, we have the, center of gravity also. Center of gravity for some of the figure like the solid sphere, hollow sphere. Is it done? All of you have noted down? Is it done, guys? Is it done? All of you? Now, note down the moment of inertia. What do you mean by the moment of inertia, guys? What do you mean by the moment of inertia? Anybody know something about moment of inertia? We represent it by I. We represent it by I. Anybody know about the moment of inertia? Moment of inertia we also call second moment of area. Second moment of area. Sometime in the some other subject, it might be written second moment of area. That is also same thing, right? How to calculate the moment of inertia? How to calculate the moment of inertia? What is the exact formula and what is the exact definition? Anybody know? Moment of inertia, resistance to rotation. See, moment of inertia is two types: mass moment of inertia and area moment of inertia. We have the two things. What is the formula we have? The formula is, note down, summation of A. Suppose you are calculating the moment of inertia about xx, you just take summation of area. You just take summation of area. Suppose if I talk about the area moment of inertia, area into y square. Iyy you can calculate summation of area x square. Note down, guys, very, very important. Resistance to what? Movement. Whatever the movement is there, if any resistance will be there, that tendency, that property will be called as moment of inertia, right? Moment of inertia is also calculated as A into k square, where k is nothing but radius of gyration. Where k is known as radius of gyration and A is nothing but area, right? Some of the rectangles is there. What about Ixx? dBq by 12, bdq by 12. Iyy, note down the formulas. Some of the common figure formula, moment of inertia, very, very important. For hollow rectangle, many times in the examination that has been repeated. This question is from GATE 2015, right? And these are the things that will be used in SOM equation frequently. When we try to solve the deflection problem and the bending stress problem in the beams, there will come to know. What is the unit? Kilogram, what will be the unit? Meter to the power, what? 4. Area is what? Meter square. X is what? Meter square. So meter to the power 4. That is what we are calculating moment of inertia. That is area moment of inertia. Specifically, I am calling area moment of inertia. Detailing will be given in the GATE course about the proof and all. Is it done? Done, all of you? Now, note down, very, very important, very important. When we talk about the twisting moment or torsional stresses in the SOM, there we will try to solve by the torsional equation T by J, tau by R, G theta by L. There we come to know the polar moment of inertia. There you come to know the importance of polar moment of inertia. And for that, you need some moment of inertia calculation. For that, you just note down this thing. Very, very important. Either you calculate Ixx or Iyy, it's same thing. Ixx and Iyy both will be pi d to the power 4 divided by 64. Very, very important. For hollow circle, this will be the formula. Very, very important. All of your understanding? So these are the outline of the course that engineering mechanics I try my level best to cover in particularly 8 hours, right? So we generally take for gate examination around 25 to 30 hours, right? In that we try to cover mostly all the problem that is very new, conceptual problem that we are taking directly from NPTEL also, because if you just take the NPTEL problem PDF from the NPTEL website, the solution is not given, only answer is given. Then you have the problem. Suppose you got the answer by hook and crook, suppose any way, any chance, but you don't know whether concept is correct or not for that particular question. That will also be covered in the particular class, right? So you can have the difference between 8 hours and 25 hours. There's a lot of differences there, right? But still I try my level best to cover the outline at least. What is the boundary? Within that we need to play, right? Understanding my point? Tell me, guys. Perfect. Right. So thank you all. If you have any doubt, let me know. Otherwise, we can leave for the day. Do not worry. In the strength of material, whatever the things, center of gravity, right? Centroid, moment of inertia, all the things will again come. And there we will be knowing in detail while solving the numerical. So do not worry that we did not cover the problem for that. Do not think about that, right? Okay. Thank you all. Yes.